Right, well here we're back with the Grundig 3060, and I've got to tell you that all my usual planning on going through these restorations in an orderly fashion has just gone out the window, because this thing needed a lot of mechanical restoration and repair. I've done quite a lot, and I've got to admit again that some of the video that I took during these phases has gone haywire. It's gone. So I'm just going to go part by part and tell you what I've done so far. You might notice that there's a new coat of shiny gold on the chassis, and that was done by painting with a very carefully with a paintbrush after cleaning it up. And some of it has some of the markings and stains are still showing, but that's fine. At least it's protected from the elements, and it shouldn't rust again. And so you can see straight away that transformer is in place. I chose the second of the two that I showed earlier, and the reason for that is that I didn't need many options on the power supply. I didn't need the 120, 115, 200 volt options. I just needed the 240 volt option, which is wired in there through the fuse, and it's got a new power cord in place. Okay, power cord is in there. It's all been cleaned up, and the transformer has been screwed in place with these two brackets. So that is all done. The back end there has been cleaned a little bit, not completely, but all the wiring is proper. I've got 220 coming in now through the switch. This Selenium rectifier was flapping around, and it also made pretty uncomfortable noises. So I took it apart, removed all the elements inside, put in four 1N4007 diodes, basically made a bridge rectifier on there. So that's been restored. Everything here has been cleaned. All the knobs, as you can see, are shiny and have been cleaned up. If we go on to the flywheel, that's also been cleaned up. All of that has been done. The tuning capacitor has been totally removed and cleaned and oiled. That in itself is quite a job. You can see this bracket holding the ferrite antenna. That was sanded and resprayed. There's a heck of a lot that's been done, as you can see, but it doesn't look like much when you look at it like this, but well, yeah, the hours have clocked up. That was cleaned up as well. All the IF cans have been cleaned up. They were actually removed for the painting of the chassis and then cleaned up properly. As you can see, those IF cans are all looking quite pristine. So basically, I've got this to the point where it's been wired up. I have tested the supply as far as the filter caps. That filter cap can was actually, I disconnected the capacitors, tested them. They were fairly high, and they were leaking very badly. But once I put them on the capacitor restoration reformer, after a couple of days, and I mean a couple of days, about a day on each, I got the leakage of each of those caps at 330 volts down to about 60 microamps, which is fine. But they started off with you know, about 12 milliamps. So you can see the difference when you put them on the capacitor restorer. And you've got to do it very carefully, very slowly. Take the voltage up very slowly. And the result, I hope, is a hum-free power supply. So that's the top side. And let me turn this around and show you the underside, where not much has changed. Now the underside is pretty much as it was. With the exception of some cleaning, nothing much has been done here. And that is because that will start with the electronic restoration. I did some cleaning on there. The continuation of the cleaning from the top obviously extends to the bottom as well. But other than that, there's not much done on there. All those capacitors are still original. I haven't checked resistors, I haven't checked much at all. Now let me show you the faceplate. This faceplate was completely removed, everything was taken out of it, and it got a new spray job on there. So it's looking quite sharp. That's the one side. This is the other side. This is actually the back side that goes to the back of the radio. But as you can see, it's now looking completely different. So the challenge now is to start putting this thing together. I'm going to have a hell of a job with all the dial cords because some of them are broken. These dial cords are partially, they seem to be a sort of a nylon, and the other half is steel. So I have to find alternatives for that because those are broken. And I can now start on the actual restoration, which is the part that I enjoy most. But at least some of the really crappy jobs have been done. So it makes it easier to go through the next stage and hopefully get this thing working. I have no idea whatsoever if this thing is working. The tubes are out. I've done a hell of a lot of work even before knowing whether this thing turns on or not. So I hope I don't regret that. But we shall see. There's no reason this thing cannot be brought back to life. The schematic has been printed out. It's not that complex. There are a lot of capacitors to change on here. Everything seems to be fairly accessible. There isn't much that's really impenetrable over here. The capacitors actually have their value written on them, which makes them easier to test. And rather, the resistors. The capacitors are a variety of pretty strange looking ones that I haven't come across yet. I've come across all sorts, but not these. So I don't know whether they leak completely, but I'm going to change them all anyway. And report back when I've got some of these circuits done. Well, here we have the next stage, and when I finished off, I hadn't put the front plate on, and I hadn't done any restoration internally. As it happens, both of those jobs have been started, in some cases completed, and I'll show you stage by stage. The first step is obviously you can see the front plate is in, and with the faceplate is the obviously the dial cords have been put in place, which was, as expected, one hell of a job. The AM dial cord had the metal part, the steel part, completely rusted and broken. So I replaced that with that top one there that comes off the spring. The cord itself goes round and is fine, but the steel one that you see there is completely new, and that is actually a guitar high E string. So it's resilient, it does the job, it's fairly easy to get, and that's what I've used. So that dial cord system is in place. Then with the FM was actually simpler because it's the lower one, that one down there. That one didn't have a broken steel part, so that was just fitted in place, wound round the respective number of times, which is always a bit of a challenge. The biggest challenge there is to get the right positioning of the dial cord itself around that pulley, and if you don't get it right, then your tuning doesn't take it to the two extremes, on the capacitor at the same time as it does on the dial itself. So you have to be very careful. Now, you can use all sorts of things to do that. One of them is trial and error, which is a pain in the butt. But I do have a schematic of this. So there's the actual drawing for the dial cords. And I've got to tell you, it wasn't worth much. I know that you can actually use only these to get it done. I know that if you follow them very carefully, you'll get that done. I prefer to use the system that I showed you in the previous video, which is to record just short clips, just with a camera, the phone camera. As I remove them, I tend to be able to replicate or reverse that process a lot easier than going through these. But you can go through these. It's a little bit tricky to get the right number of turns and to try to figure out which part is on the inside of that pulley, which part is on the outside. And yeah, well, using the videos that I did, the short videos that I did and showed you before, and actually referring to these drawings, I managed to get that thing sorted out. The actual length of that broken steel cord was not measured according to these over here. I just put it in place and I tightened it to where I felt it was right. So you basically put it in temporarily, tack it together, test it out, and then you tighten it to get the right tension on the spring and get the function to work properly. The most difficult one, believe it or not, is actually the antenna rotator, because it goes through various points here. You've got those guides in there, you've got that which has to rotate, you've got the rotation on the back of that volume pot, and then across on the actual antenna assembly underneath, you've got another section that has to fit in place. Now, I've got it sorted out. It's working right. It's going to the two extremes. And this was after, 3, 4, 5, 6 attempts. You just have to be patient with the stuff. It ends up fitting in place, which is great. As for the rest of the actual faceplate, not many problems there. Again, I followed some of the videos that I'd taken of dismantling this thing to get the screws in right. All the screws were derusted. Dial lamps have been put in there. They were burnt out, so I put some new ones in there. And the whole thing fit together quite nicely. The magic eye is in place. It fits in the back part of the faceplate over there. I have no idea if it's working. And this is true for most of the radio. The only part that I know works is as far as the tuning, as the filter caps. The two 50 microfarad filter caps inside that can. I know that the supply is working. I've tested the heater voltages on all of the tube sockets, with the tubes out, of course. And then I went on to the next stage, which is the real start of the electronic restoration. And I'll flip this over and show you. Here's the proof of the pudding. This is what's been done so far. And as usual, I used my coloring in technique to complete all the checking that I've done. So everything I've checked is in green. Capacitors there that you see in blue are the ones that have been changed. Some of them were not necessary. But the ones that were not necessary to change were some of the mica caps, a few ceramics that are in here, but the rest were literally all worthless. Some of them were incredibly leaky, all of them way out of range value-wise, so I just changed them. The electrolytics weren't too bad. This one here, this is the output tube. You've got your bias resistor over there, 170 ohms. Oh, that was dead. That was completely dead. Now I'm telling you this without having tested it yet, but when I do the test on the resistors, that thing was completely dead. It was burnt out. So I replaced that one, and I replaced the capacitor here, which was way off range, and I didn't want to reform it because it was just too wrong. So that one's been changed. A couple of others. There's one here somewhere. No, that one's also been changed. That's a small electrolytic that I just changed because it was also out of range, and it's a this one's a high voltage. This one's a low voltage electrolytic. Going through this, nothing too serious, nothing too dramatic, with one exception. You'll notice that where I started the restoration, as I said, I wanted to do power supply, and following my normal routine, if you can call anything about this restoration normal, I like to go on to the power amp stage. And for me, the power amp stage is from the pickup input. So you see the pickup input is actually the start of the green, all the checking. You'll notice the tubes haven't been checked because I don't know if they work or not. But all that has been changed, and what you'll notice here is this section over here is kind of busy. Let me zoom in and show you that. There's the pickup. It goes into there selected as pickup, goes into there selected as pickup, and that then goes through that 22 nanofarad capacitor into the grid of this first triode, which is the first preamp, audio preamp of the system. Now this triode and that triode are the two that form the ECC81 tube. So this first triode, which is biased through this resistor network, that 22K, 33K and 22K with a 4 microfarad capacitor here. So that's the B plus. The signal comes out through this 220 nanofarad capacitor. Now this is where it enters this crazy scheme here with all these pots, which, just to make it more fun, they're actually sort of strange dual pots, and they can work together or separately. Now they're connected together in some cases and separately in others. You'll see 1, 2, 3, 4. These are obvious, but there's 5 in the front, and the fifth one is actually, half of the fifth one is here and the other half of the fifth one is here. Now this is slightly different. It's different to what we see here, and let me just explain basically what's happening here. What's happening is that the signal that comes out here then goes through or meets a series of bandpass filters centered on different frequencies. The other schematic that I've managed to find actually labels very unclearly what these frequencies are. But what I can read, from basically what I can read, this one here is 150 Hertz, that one there's 1 kilohertz, that one there's 3.6 kilohertz, and then the other one just says H, that one there says H, and the last one says B. Now I think this is the higher frequency one, and this one says B, and that one says B, which I think is bass. And these are the same pot, but just in different parts of the circuit, obviously physically located in the same place. Now, these here are simpler because they actually affect the output signal from that preamp. They shape it. In other words, they will attenuate certain frequencies and boost other frequencies depending on how they are tuned through this capacitor, that resistor, and that inductor. This line has an inductor in it as well, that one has an inductor in it, and that one has an inductor in it. I'll show you those inductors in a minute. Now, the other ones, that one there doesn't. And this one here is actually just reference to ground. That would be the higher frequencies. It just is a 10 nanofarad to ground. This one here is a little bit more complex because this one actually comes from there through another 22 or 0.22 microfarad capacitor. And it then has a shaping effect there and goes back into a feedback system, back into here, right, or rather into there effectively. So it's basically a feedback network that affects the bass. It is also partially here, the other half of it, which is the feedback from the output transformer. That line over there, 3.3K, goes into there, through through those two, and then to ground. So this is a feedback loop that'll affect the range of the volume pot, which is over here. So pretty complex. These guys really went to town on getting their so-called magic sound. The beauty of it is that I've seen it working on other radios. I'm hoping that I'll get the same effect here. I've changed all these capacitors, and I'll show you that in a minute. All these pots are moving very smoothly. Everything's working fine mechanically. I'm just hoping to see that they work electronically as well. So that is the only real difference with this particular radio. It doesn't have a simple tone control. It has an actual equalizer, which is quite cool. Other than that, things are pretty simple, pretty standard. The speaker arrangement is not exactly the same as is on this schematic. I have the other schematic, which is printed out on 3 pages. It's a lot bigger. However, it's not as clear. So I've used this one, and whenever I find a discrepancy between what I find in the radio, in the circuitry, and the actual schematic, I refer to the other one, and usually I've noticed that the other one is more accurate. For example, this here, which is a network that comes from the output of the EL84, that part doesn't exist, in fact. And in the other schematic, this is not in there either. So this must have been a different version. But enough of that. Let me show you the actual underside of the chassis, and you can see what I've done so far. As you can see, it looks like it's been hit with a strange kind of yellow fever, but that is proof of the replacements that I've made, and it's a lot. This is quite a lot for a radio. I don't usually have this many capacitors to change, but the reason for that is, as you can see here, this is that the tone controls, the 5 tone controls over here, and each of them have got these capacitors in place. So they were all replaced. This is also has part of the audio feedback circuitry and feed forward circuitry, so those yellow ones are all replaced, as are those. That tube there's the ECC81, so one will be the input and then another output capacitor there. All resistors here were fine, no problem at all. And then we'll see a little bit more here. Those capacitors were also replaced and everything else was checked. Everything else is fine. There was one exception, which was that resistor over here. That was the 170 ohm. I replaced it with an old one that I had, which is 170 ohm, and it actually fits better, looks better there. It looks like it fits age-wise. The electrolytic capacitor you see below that is the cathode bypass cap. That's 100 microfarad 50 volts that I put in there. It's an Ishikon. On the underside there you see a blue capacitor. That was a 4 microfarad that also needed replacing. Electrolytic. There are still some capacitors here that have not been changed. You can see that blue one at the bottom there. There's another teal bluish one over there. There's a couple of brown ones over here. Those have not been changed because I haven't gone back further in the circuit than the audio stage. This is the RF stage, so you see that Eero cap there. That looks really rotten. But yeah, so this stage hasn't been touched because it's all RF. So what we have here so far is that all the audio stage, the audio amp, has been recapped, and I'm dying to test it. And that's what I'm going to do next with, in fact, when I test it, when I switch it on for the first time, we'll be able to see if the radio works at all. Something else I want to show you is this over here. These are those inductors on the graphic equalizer circuit. Pretty beefy stuff. And they are fairly far away from the actual circuit. They connected here on the side. So the next step is just to get this thing connected to the light dimmer circuit and power it on for the first time, see what we've got. Okay, so ready to do the first power up, and after all this work I just pray it works. Now what I've done is I've connected an external speaker. That one over there is connected to the external speaker connector over there. I have not used the other connectors, which I've taped on here very carefully. One of them has actually got high voltage for the electrostatic tweeter. I've insulated that. I've plugged in the radio to the light dimmer circuit there, and protection is on, and only one light is on, so it's got the maximum protection possible. And we'll get ready to set it up, to start it up. So what I'm going to do, I've connected some antennas outside, from the outside to the radio, just to try and get something. Let's be hopeful. And I'm going to put it on, let's put on medium wave. It's on medium wave. Obviously it's not working because that is off there. Now I have these three off. I've only got that one on. Volume, not somewhere in the middle. Let's put it somewhere in the middle. And here goes. Jesus. Okay, here goes. Okay, all right. No shorts. The light went bright and then dimmed, which is good. Our line voltage being seen by the radio is 236 volts. There's almost no drop. Still don't hear anything. The lights are on. Oh yeah, I do hear something. The light has gone slightly brighter as the tubes start drawing. Let me tune this and see what we get. This is on medium wave. Ha! We've got liftoff. Brilliant. Let's try shortwave. Bit more volume. Yes.
Familia do Norte, or Northern Family, left more than 50 people dead.
Oh, great stuff. Now for the final test. FM, please. Oh dear. Well, FM is deaf, but let me give it more power, so I'm going to add another light to this. Ha! I don't care how hissy that is, at least it's got something.
Fiquemos, pois, com esta música bem vestida e barroca no
That's
concerto.
pretty good. Bloody brilliant. Let's try these guys. that definitely makes a difference. That one too. Love it.
Desta reunião de imprensa, o treinador do Benfica, Rui Vitória, dizia que não aceita o que conquistou até agora.
Não aceito e não admito que metam em causa aquilo que é o mérito, neste caso do Benfica, que nós temos tido ao longo deste trajeto.
Right, they're all a minimum. Let's try the difference now.
Porque os meus jogadores têm sido fantásticos. Aquilo que nós tem sido conquistado dentro do campo, 11 contra 11, sempre com uma entrega total, uma dedicação total.
You definitely see a difference in bass there.
A ultrapassar mais obstáculos, mais dificuldades. E aquilo que temos vindo a ganhar, eu não aceito que o metam em causa. E serei sempre aqui uma voz muito ativa, muito presente na defesa dos meus jogadores e na defesa da minha equipa.
Declarações do treinador do Benfica durante a conferência de imprensa.
So the graphic equalizer is fine. We've got FM, which is great. I don't have to mess around inside that can, which, as if you've seen any of the previous ones, you'll know that that can be quite a nightmare, and I hate it. Not afraid of it anymore, but I hate it. Yeah, there's still a few things to test here, but I haven't tried the ferrite antenna. According to that little lamp there, it's actually on. Let's see. That's that thing over there. Oh, it does switch it off. Okay. Well, I'll test that more thoroughly when I've got the radio recapped, the radio section. So yeah, okay, I'm very pleased. I'm glad this work wasn't all for naught. Still a long way to go, but at least the main question is answered. I've not wasted all my time on this. And it looks like we're going to get a very, very good result from this guy. The faceplate obviously is not here. That still needs cleaning and some restoration because, as the viewer pointed out, I lost some of the printing on it on removing it from this front here. Apparently that's quite common, but it's a pain in the butt. Anyway, radio stage coming up, restoration part, and so far so good. See you soon.